All right, welcome back. This video is the first of two sequence videos. So C12, we're going to be looking at arithmetic sequences and really connecting them to just linear structure. So these are really things you've seen before in a slightly different format. So our goal for this video is I can recognize an arithmetic sequence as a linear pattern, use common difference like slope, and write a general term. So you can see our hook here is a secretly aligned. So you have a sequence 6, 10, 14, 18. So I've kind of made a table of values. So you can see n is the term number and then tn is the term. So pause for a second here and you're just kind of asking yourself, so what's changing by the same amount? And then if this were a line, like if you were to graph these points, what would be the slope? And we will solve this question in I do one. So pause it, try the hook, and then we'll come back. Okay, so yeah, hopefully this does look really familiar to Math 10. If we look, we are kind of just asking ourselves, well, what's the input and what's the output here? So if I looked at this, I'm going to say, well, n is the input and tn is the output, right? So then what I see is, well, when my input goes up by 1, so I go from 1 to 2, I go up 1, I go up 1, I go up 1. Well, what's my output doing? I'm going up by 4, 4, 4. So my common difference then is 4. Now, if I didn't have the table of values, what I would have done, I'll just zoom out a little bit here, is I would say common difference is going to be the difference between any two consecutive terms. For example, T2 and T1, which in this case was 10 minus 6, which is 4. What's the first term? Well, that's easy. I'm just going to look. What's the first term? 6. So T1, first term, is 6. So then remember, for arithmetic sequences, we have a general term. So the general term, we say, hey, any nth term is going to be the first term plus n minus 1 differences. So here we can say, well, the general term is going to be first term is 6 plus n minus 1 times 4. So that's our general term. Now, usually, like we're happy with that, right? So we're going to say, hey, like, Tn is going to be 6 plus, and you could put the 4 on the front if you want, 4n minus 1. But if we want to make that linear connection explicit, what we can do is keep going on this one. So we're going to say, well, Tn, if we expanded it, it's going to be 6 plus 4 times n minus 4 times 1, which is going to be 4n plus 2. So we could say, or the nth term is 4 times n plus 2. So if you take a look kind of connecting it, well, we can see that the slope for both of them, linear connection, that slope is 4, right? So we can see that 4, that kind of rate of change is the same. So, well, what's different? Well, first, if you look over here in this first term, that's not the y-intercept. We can see if this were a line, the y-intercept is going to be 2. So what we could say down here is we could say, so T1 is not the y-intercept. That's a difference we have to watch. That just has to do with the way we count numbers. And then we'd also say for the sequence, we don't have continuous data, we have discrete data. So the sequence is discrete, right? So what we're saying here is n is an element of, so n can be 1 or 2 or 3. Nothing in between, no negatives, no 0. Said another way, n is going to be an element of the natural numbers, the counting numbers. Okay. But with that said, it is a linear pattern, right? So we see a slope. We're going to go up by a constant amount. We have a lot of linear things in here, especially if we do this kind of final simplification to make it look straight up like a y equals mx plus b. Okay, so here's one for you. So yours is going to say, here's a sequence, 21, 17, 13, 9. I'd like you to identify the common difference, the general term Tn, and find T12. And again, if this looks different, just think it is just a linear question. I'm just giving you 4 points on a line, and you're kind of adding, okay, well, I know input is 1, input is 2, input is 3, input is 4. Okay, So try this question and pause it, and we'll kind of come back with the solution. Okay. So here is your solution. So as you can kind of take a look, we have that difference is -4. My general term is 21 minus 4 t minus 4 times n minus 1, which could simplify to 25 minus 4n, which makes that connection explicit again. So you can see in green there, if this were a line, in line world, we're saying, well, m is -4 and b is 25, which is a y-intercept of 0, 25. And again, just kind of notice that would be like term 0 in the sequence. So the term before term 1, which in the sequence won't exist. And then if I want the 12th term, that's going to be -23. So just kind of continue the sequence. Yeah, so, and then just note there we did a negative common difference, a negative d. So all that means is the sequence is decreasing, just like a negative slope means a line will drop as you read it from left to right. So that's it. So that's kind of like, hey, what if we have the whole sequence? Our next questions are going to say, well, what if we just know 2 known terms? So if I take a look at this one, I do too. I do too. 2 known terms behave like 2 points. So problem here is an arithmetic sequence has term 3 is 15 and term 8 is 35. Find a general term. Now, first, the fact that they told us it's arithmetic is huge because we don't need to worry about it being possibly geometric or something else. So what we're going to say is, well, what do we know? So if I go back to input-output language, remember n is the input, x, and then tn is the output, y. So what this question is really telling me is, well, I know if I input 3, I output 15, and if I input 8, I output 35. Well, from Math 10, I can really easily find the slope between 2 points, right? We know that slope is the change in y output over the change in x input. So here I'll say, well, so my slope is my y ends up at 35 and it was at 15, and my x ends up at 8 and it was at 3. So that's going to be 20 over 5. So my slope is 4. Now my slope in this case is really the common difference, which is also 4. So once I know that, let's go back and find T1. Because again, we can say, well, I know, for example, my third point. I know my third point is 15. Now I know my third point. The way I get to my third point is I have T1, T2, T3, is I've jumped up by D twice. So really I'm going to say, so T3 is going to be T1 plus the difference twice. I know the difference is 4, and I know T3 is 15. So 15 is going to be T1 plus 2 times 4. 15 equals T1 plus 8. So T1 must have been 7. So that's that kind of sequence format. You could do a very, very similar thing using the line, right? So we could kind of work backwards from that line as well. And then Tn, if I want Tn, I'm going to say, well, I know Tn is T1 plus n minus 1 times d. So Tn, now that I know T1 is 7, n minus 1, and I know my difference was 4. So that is the general term. If I want to, again, make that explicit connection back to lines, I'm just going to expand that out. So 7 plus 4 times n minus 4 times 1. So Tn would be 4n plus 3. And again, that kind of shows you that, hey, that slope is the same, input output is the same. The only difference is the y-intercept would be 0, 3, which would be term 0. And that's it. So again, you can see the same structure is found in a line with 2 points. The difference is we have term numbers. And then again, n does have to be a natural number, so that has a little parameter for us. So one for you to try there quick. So from two terms, I'm going to say arithmetic has sequence has fourth term 11 and ninth term -9. Find D, T1, and Tn. Try it now, pause it, and come back for it. Okay. So very, very similar question. I set this one up more arithmetic sequence-wise as opposed to linear-wise, but again, similar like in previous videos, right? We're not solving a brand new question. We've seen this material with linear functions. We're just applying it in a different context. So wrapping this one up, final checklist of things we're looking for. So check that the difference between consecutive terms is constant, especially if the question doesn't say it's arithmetic. You have to confirm that. If it is, that common difference d is just like the slope m. We have that general term Tn equals T1 plus n minus 1d. Term 1 has used 0 differences, right? So that is the first term, but it's not the y-intercept. The domain is the natural numbers 1, 2, 3, so the graph is going to be discrete, not like continuous like a line. And that first term is not the y-intercept. The y-intercept is one step before t1, so it would be t0 if t0 were allowed in the sequence. And that's it. Thanks for watching.